Hello everyone. Today we are going to solve this permutations and combinations question, which was part of permutations and combinations week in my Facebook and WhatsApp group. The goal in this permutation combination week for me is to actually impart as many concepts around permutations and combinations I can provide, and hence I have intentionally kept the questions a little different so that I can talk about some of the concepts involved and contrast some of the ways we solved certain things. So this is one of those questions. My hope is that after reading this question, you find yourself a little better at permutations and combinations than you were before, and it is a series of questions, so hopefully the next questions do the same. If you find this video helpful, don't forget to like my video and subscribe to my channel. It really helps me and keeps me motivated to create these free videos for you. Okay, so let's get started. One of the most important things that you need to learn in permutations combinations is spotting whether it is a arrangement question or is it a selection question where the arrangement is not important. And a lot of times it is not easy. A lot of times same looking questions may have different interpretations. So you have to be very careful and understand spotting the difference. And if you spot the difference, the solution from there on depends on how you strategize the solution. So let's look at the wrong method to solve this question. Although this is the wrong way to solve the question, I suspect, since this is a basic kind of question, not a lot of you are making this mistake. However, let's just read through the question and understand why some of you may get it wrong. So M is the number of ways of distributing 3 prizes to 5 students. So there are 5 students and 3 prizes are to be given to them, and in a manner that no student gets more than 1 prize. If one student could have gotten more prize, the answer would be slightly different. And then N is the number of ways of picking a team of 3 members from 5 students. So the biggest mistake people make is thinking that these two are the same things. And since these two are the same things, M is to N would be 1 and mark 1 as the right answer. That's the biggest mistake. So the biggest mistake is saying that M is getting 3 students from 5 and giving them prizes, and N is also getting 3 students from 5 and putting them in a team. So they are kind of the same, and hence the ratio of M is to N would be 1 because they are the same instances. And the mistake you're making here is again of arrangements. Where are arrangements important? And this is important for you to understand because arrangement, when important, make a difference. And if you are not able to spot the difference, now this is fairly simple question that I have created to demonstrate this difference to you. However, sometimes the differences are not that apparent, right? So we'll talk about that as well. Here you see that the 5 students are supposed to be given 3 prizes. So these 3 prizes are of course not the same, right? P1, P2 and P3. And if you have 5 students, if you have 3 prizes, you can give the first prize to any of the students, right? So that's 5 ways multiplied by P2. Since one of the students have got it, we don't know which one, only 4 of the other students can get P2. That's 4. And the next would be 3. Since the students are different and the prizes are different, the arrangement on how the students get the prizes is very important. Let's call them S1, S2, S3. So let's say S1, S2, S3. S1 gets P1, S2 gets P2, and S3 gets P3 is different from S1 getting third prize, S2 getting second prize, and S3 getting the first prize, for instance. These two are two different arrangements of dividing the prizes between the 2 students. Hence the arrangements matter, and that is why we call that, and this is why we call this 5P3, taking 3 students from the 5 students in a way that arrangement matters. It matters how you are dividing them. On the other hand, when you have a team, let's say you have a team of student 1, student 2 and student 3. This is a team. Does it matter if I have student 3, student 1 or student 2? It does not, right? Because it's the same team. It still is the team of 3 members. However, if I were to divide them as captain, vice captain, and the third member, then arrangement would matter, because now the team's composition depends on who I chose as captain, and team would look different. So even if I call it a team and you think, hey, arrangement doesn't matter, it's not going to be the case. Sometimes the arrangement does matter, and you have to be on the lookout for those kind of words in the sentence. So let's look at some of the words and meanings that would trigger arrangement or non-arrangement kind of thoughts in your mind, and then we will look at the right way to solve this problem. Okay, so here are some of the terms that should trigger arrangement versus selections question, at least in your mind. Some of these terms may be there for as a trap, so just make sure you understand the context when you are looking at these terms. So prices, positions, distinct, different, unique, all of these words should trigger, oh, arrangement is important in your mind. Similarly, when selections is another way to say arrangements are not important, should trigger when you are selecting a team. However, we just talked about that if the team has a captain, a vice captain, and other members, then arrangements may be important. Team, groups, identical, similar, same size and shape, all of these should trigger in your mind. Doesn't look like arrangement is going to be important, but let me read through the context of the question and really understand it. Hopefully this was clear. Now let's look at the proper solution to this question, and it will be very short. Okay, so M, as we already did, is the ways of distributing 3 prizes to 5 students. So since prizes are going to be 3 different prizes and each student must get one, the first prize can be distributed to 5 students in 5 ways. Any of one student can get it. The second prize would be given to the students in 4 different ways, because one of those students has already gotten the prize. And similarly for the third prize. This can also be written as 5P3, and which is also equal to, which is same as, this is called the counting approach to solve the problem, and this is called the P&C approach to solve the problem. As the problem gets bigger, applying the permutations approach to the problem becomes easier, because you have this notation that can be opened up anytime. Now let's take N. N is saying number of ways of picking teams of 3 members. As we talked about, student 1, student 2, and student 3 is one arrangement, and if we were giving them prizes, distinct prizes, it would be different than putting them in team. Technically, both of this, because it consists of the same members, are going to be the same team, even though they are different arrangements. Since in N, we care only for the selections of these students, not their arrangements, we are going to do 2 things. We can take the counting method, 5 multiplied by 4 multiplied by 3, and divided by the number of possible arrangements between 3 people, which is 3 factorial. Or we can write it as 5C3, which is nothing but 5 factorial divided by 3 factorial multiplied by 2 factorial, NCR multiplied by n minus r factorial. Both of these are same. Again, this is the counting method of doing things, and you will find this helpful when you are doing arrangements in sometimes. This is the permutations or combinations way of doing things, and it becomes easier when you have large quantities of when you are dealing with large quantities. And there is some of the rules that could be interchangeable and interapplicable, and we will talk about that later. So M is to N would be 6. So the answer to the asked question is D, 6. Ratio between M and N is 6. In the second question, however, everything is switched. Since the prices are look-alike, who gets what prize doesn't matter, and hence the arrangement doesn't matter. On the other hand, even though we are selecting a team, the makeup of the team matters. So if Mike were a captain and Sally was a vice captain and Joe was a manager, it would be a different team than if Mike were a vice captain, Sally was a manager, and Joe was a captain. So here arrangement would matter. In the end, the answer would be flipped, right? Instead of 6, it would be 1 by 6, but I wanted to demonstrate how a simple change in the context or the sentence can make a difference in permutations and probability questions. I hope you found this helpful and you learned something new today. Please stay tuned for other questions in the permutations week. In the next questions, we will talk about some of the other more involved concepts in permutations and combinations through probability and other methods. If you have any questions or doubts, please feel free to comment. I personally respond to all the comments. Thank you. Bye bye.